Hey guys, how's it going? This is Ryan from O2BT here with another video in our technical interview prep series. Today we're going to write a function to tell whether an integer is a power or 2 of naught. And this function is going to be very quick and it will not involve recursion. In order to do this, you'll need some basic knowledge of binary. Alright, let's get started. So here we have the framework for a program here. It's going to prompt the user for a positive integer, enter -1 to quit, and all it's going to do is it's going to call this isPower2 function and tell you if that integer is a power of 2 or is not a power of 2. And to do that, we need to know some binary. We're going to start by thinking about how we represent a power of 2 in binary, and we're going to notice a pattern. So the first example I have here is think, what is 8 in binary? Well, it's 1, 0, 0, 0. And remember, this is 1 times 2 to the third, plus 0 times 2 to the second, plus 0 times 2 to the first, plus 0 times 2 to the 0. Let's write down some other powers. So 16 in binary is 1 followed by 4 zeros, because it's 1 times 2 to the fourth. And let's think about some more. So 2 is obviously 10, and then we have 4 is 1, 0, 0. So you start to see a pattern here that any integer that's a power of 2 is a 1 followed by all zeros. And so we're going to exploit that bitwise representation of that integer in order to create a very powerful and fast function. So notice here, let's say we're talking about 3. What's the binary representation of 3? Well, it's 1, 1. Or I'm actually going to put a 0 out here. And we're going to start to notice a pattern. What about, say, 15? Well, that's going to be 1, 1, 1. 1, 1, 1, 1, I'm sorry. And I'm going to put a 0 out front leading. That doesn't change the value or anything. And so if we're starting to compare a power of 2 with the number directly below it, we notice, for instance, that 4 is a 1 followed by all zeros, and then 3 is a 0 followed by all 1s. Likewise, this pattern holds for 16. We notice it's a 1 followed by 4 zeros, whereas 15 is a 0 followed by all 1s. So we're going to exploit that pattern, and we're going to come up with a function. So you notice, what happens if we do a bitwise AND operator on these bits between, say, 16 and 15? We'll get 0. For 4 and 3, it's the same thing, because 1 and 0 is 0, 0 and 1 is 0, 0 and 1 is 0. And real quick, you know, how we said how 2 is 10. So let's try, well, 1 is 0, 1 again. And so we notice that if we AND 10 with 0, 1, we'll also get 0. So the trick here is just to AND input and input minus 1, and we'll see if those bits are 0. So here all we have is return input and input minus 1 is equal to 0. And just for precedence operators, we need to throw in a lot of parenthesis here. So this should do the trick. We're going to return input bitwise ANDed with the number below it, and according to this pattern we've observed, we should get all zeros. And so if we observe that this is true, that a number ANDed with the number 1 below it is all zeros, we can conclude that that's a power of 2. Alright, let's go to G++, and we'll see if this compiles. Oops, just missing a semicolon. Classic amateur mistake here. Awesome. Alright, so we'll fire that up. Enter a positive integer. Enter -1 to quit. We'll say 5. 5 is not a power of 2. What about 6? 6 is not. How about 8? 8 is a power of 2. We'll try 16. It is a power of 2. 32, 64, 128, 255. So you can see that this has been pretty accurate for our test cases so far. Alright, thanks for watching, guys. I hope you learned a little bit about how to manipulate the bitwise representation of numbers in this video. And don't forget to subscribe, and we'll see you in the next video. All right, thanks.